Have you ever made a sound in a large, empty room? The echo you produced would have died out in a short while, but that is not the case with a massive object that scientists just discovered in space that has been sending out an echo into the cosmos. What is this enormous object? Why is it sending out an echo? Will it ever keep quiet? Join us to explore the massive object that scientists say has sent out an echo into the cosmos and to other deep space mysteries. Echo is not always desirable. Building engineers spend lots of time preventing echo when building large structures like theaters and halls. However, when it comes to space, there is nothing to prevent echo, and one dying object in space has been discovered to be the source of a massive echo reverberating around the cosmos. Before you shed a tear for the dying object, it is a black hole. Many people have a morbid fascination with black holes. Thanks to pop science fiction flicks, they are presented as these insatiable objects that swallow everything that gets too close to them. But of course, filmmakers are at liberty to let their imaginations run wild, so many of the depictions of black holes may only be fantasy. The truth is, in real life, black holes are terrifying. The honor of the first black hole ever discovered goes to Cygnus X1. It is located within the Milky Way in the constellation of Cygnus the Swan. It was discovered by astronomers when a sounding rocket detected celestial sources of X-rays. And as powerful and scary as they are, black holes are numerous. The Space Telescope Science Institute estimates that 1 out of every 1,000 stars out there is capable of becoming a black hole. This means the Milky Way galaxy, containing over 100 billion stars, could host about 100 million hungry black holes. Since black holes are something to be wary of, which one is closest to the Earth? That is the one dubbed the Unicorn. It is located about 1,500 light-years away from us, safely enough, and the Unicorn has a relatively low mass of about 3 times the Sun. The black hole at the center of the Milky Way galaxy is the Sagittarius A star. This massive structure is about 4 million times more massive than our Sun and is safely tucked away some 26,000 light-years away from us. The first image of a black hole was released in 2019 using the Event Horizon telescope. It was located in the center of the M87 galaxy, which is 55 million light-years away from us. Meanwhile, you can't see black holes the way you can see a star. What astronomers do is look for a way to detect the radiation black holes emit as dust and gas are drawn into them. But for supermassive black holes, which are at the center of a galaxy, they may become shrouded by the thick dust and gas around them, which can block the telltale emissions. Black holes have 3 layers: the outer and inner event horizon and the singularity. The event horizon is the point of no return as far as black holes are concerned. Anything that goes beyond that point is gone forever. Even light cannot escape. What exactly happens if you fall into a black hole? While you shouldn't try to find out, scientists have long theorized that gravity would stretch the victim out like spaghetti. However, new scientific work suggests a different outcome. The quantum effect could make the event horizon act like a fiery wall of fire and instantly burn the visitor to death. Now, do black holes die, or do they get to live forever? This question is relevant because eventually the universe will become full of only black holes. The universe is in its stelliferous era, or the period when stars and galaxies are being born. The ingredients forming these stars and galaxies will eventually be used up, and the stars themselves will slowly die out, and only black holes will remain. These voracious objects surely know how to survive. However, black holes too will die. Even though they have the power to destroy everything that comes their way, in the end, it is their strength that leads to their death. However, black holes don't go out quietly, they create a spectacle. Black holes eat up everything, but what happens when there is nothing more to guzzle? This is where problems start for a black hole. It will begin to evaporate. The black hole steadily shrinks in size and loses its mass. As this process accelerates, the rate of particles escaping from the black hole also increases before eventually erupting in an immense explosion of energy. The massive eaters can prolong their lives by finding things to consume, meaning they can buy out time for themselves. However, regardless, the time will come when they have to die. One such black hole is the ARP 187. It is a supermassive black hole that scientists also refer to as active galactic nuclear, or AGN. AGN spew large amounts of radiation like radio waves. They're also the cause of the twin jets of ionized gases normally pictured shooting away from galaxies. Researchers led by Japanese astronomer Kohei Ichikawa are responsible for spotting ARP-187 in its death throes. It is helping the space community learn more about the last days of AGN. Ichikawa and his colleagues observed ARP-187 using the radio telescopes at the Atacama Large Millimeter Submillimeter Array in northern Chile in conjunction with the Very Large Array VLA in New Mexico. They spotted twin jet lobes, a telltale sign of an AGN, but they couldn't detect radio waves, which also should have been coming from an active nucleus. But the team didn't give up. They looked at ARP-187's score again, this time using NASA's Nuclear Spectroscopic Telescope Array or NuSTAR X-ray satellite. While AGN usually produce large quantities of X-rays, they still could not isolate any such signal from the NuSTAR data. Based on this, the researchers postulate that sometime in the past several thousand years in Earth's time, ARP-187's AGN went dark. This observation is possible because an AGN's jets are colossal. ARP-187's AGN stretch out for 3,000 light-years, which means you can see their matter stream away for millennia after the AGN core gives up the ghost. This morning-like period is known as a light echo. Imagine you are watching the smoke from a newly extinguished fire. The researchers admit their discovery was by chance, but the fact is that ARP-187 could be a stepping stone to learning more about what happens at the end of an AGN's life. There are more mysteries in the universe, and as a result, scientists keep having to change their convictions. More facts emerge and they see that it is necessary to change their stance. One such instance is the number of Earth-like planets believed to be out there in space. Recent data shows that their number has been grossly underestimated. In fact, there could be double the number of these Earth-like planets than previously assumed. Scientists have discovered thousands of planets orbiting distant stars. These planets are known as exoplanets. While these findings may excite proponents of extraterrestrial life, the sad news is that the majority of these planets are not likely to be able to support life. They're either too close to the star they orbit or too far away. Conditions for supporting life have to be just right. If the planet is too close to its star, water will evaporate and there will be too much radiation for the potential inhabitants to deal with. If the planet is too far, the water freezes or the planet is made up of gases. However, as discovered by a group of scientists from the University of California, Berkeley and the University of Hawaii, the method of calculation used may be making scientists overlook evidence of a vast number of Earth-sized exoplanets in the habitable zone of their stars simply because these planets are harder to detect with current methods. They claim that on average 22% of Sun-like stars harbor a planet that is roughly Earth-sized in their habitable zones. The maths is not complicated. With about 100 billion stars in the Milky Way galaxy, that is about 20 billion such planets. In other words, each Earth inhabitant can lay claim to a few Earth-sized planets. To arrive at this conclusion, the scientists tried something entirely new in finding planets. Instead of counting how many exoplanets we have found, they went the unconventional route of determining how many planets we are unable to see. Exoplanets are discovered by watching out for the rhythmic dimming in a star's brightness. It is an indication that a planet is orbiting it and passing between the star and our view from the Earth. When using this method, large planets that orbit closely to their stars are the easiest to locate because they block more light and block more often. This is why many of the exoplanets discovered so far are large. To help them estimate the number of exoplanets this detection method misses, the Berkeley team developed a software program that analyzed data from the Kepler mission, an exoplanet-hunting NASA telescope launched into orbit in 2009. Initially, to confirm the program's accuracy, they fed it the same data from 42,557 Sun-like stars that had already been scrutinized by other astronomers, and indeed it detected 603 candidate planets, all of which had already been found. But when they made the software parse the data further to spot Earth-like planets by using the length of time between dimmings to indicate how far out the planet orbits the star, and the degree of dimming to indicate to us how much of the star is blocked by the planet, and thus the exoplanet's size, the software discovered 10 likely exoplanets that are between 1 and 2 times the size of Earth, and also occupy an orbit in what is probably the star's habitable zone. This too agreed with previous findings showing the program could detect planets accurately. But of course, their mission was to determine the overall prevalence of Earth-like exoplanets. To calculate this number, their first task was to determine just how many weren't detected in the survey. What they did was alter the Kepler data artificially by adding 40,000 more exoplanets that appear like the Earth and sending the manipulated data to their software program. This time it only found about 1% of the Earth-like planets introduced because the vast majority didn't cause a detectable dimming of their star. Accounting for this level of imperfection, the scientists calculated that there are far more Sun-like stars hosting a potentially habitable Earth-sized exoplanet than we previously thought. Of course, these scientists are the first to admit their work is purely theoretical, as they didn't actually detect any of these planets. However, provided the underlying assumptions are correct, it shows there is hope for discovering more habitable Earth-like planets in the future. They even predict that a habitable planet may be found close to us, about 12 light-years away from Earth. Let's hear what you think of black holes and extraterrestrial planets in the comments section below.